Our good viewers, you're welcome to this lesson where we are going to investigate the movement of ions during electrolysis. We are back, science education consultants. Here we are presenting ourselves to help you in a number of services. We do counseling, we do career guidance, we do online coaching, we do online Zoom lessons and many other services. Please don't be stuck. We are here to help you. Last time we studied in electrolysis that an electrolyte contains ions. These ions can be either positive or negative, and when electrolysis is taking place, they move to different electrodes. The cations, we said, they move to the cathode, and the anions move to the anode. That was kinetic theory of electrolysis. Today, we want to discuss about an experiment that can be set up to investigate this movement of ions using simple materials. We are going to use the simplest materials you can find. For example, we can use a filter paper. In fact, we can outline the materials needed, the materials used. We need a filter paper, crystals, a crystal of any colored substance. This should be at least colored, so that you can be able to see the movement. So we need a filter paper, we need copper wire, we need dry cells, we need the crocodile clip, glass slide, and crystals. And how are we going to set up this experiment? You get the filter paper, cut it into a rectangular shape, small rectangular shape that can at least fit on the slide. It should be slightly bigger than the slide, in other words. And then you get this filter paper and you attach crocodile clips together with the wire and you join it to the dry cell. Do not forget to leave a switch somewhere where you're going to connect the wires from. And then you wet the filter paper, because it is very important for it to be wet. Remember, for it to be an electrolyte, there must be a solution or molten form of the substance we are going to use. Then you put there your crystal, which is colored, and then you put there the slide and start the experiment. You will see how the experiment will move, and it will clearly indicate that actually ions move. Arrange these apparatus in this way. Get the dry cell. Now, our materials are arranged in this way, that you get the filter paper. When you have cut the rectangular shape out of it, you attach their crocodile clips. The crocodile clips are always joined. They always have where to join the wires that can be connected to the battery through a switch. So it means that you have a circuit from the battery to the switch to the crocodile clip, through the filter paper to another crocodile clip, and to the battery again. Remember that if I put here a bulb immediately after setting up the experiment like that, this bulb will not produce light. Why? The electricity will not be able to pass through the filter paper. But if I get my filter paper, I wet it, I put there some small droplets of water, and then I put there a small crystal of copper 2 sulfate, which is blue in color. a small crystal. And then, in order to have it in one position, I put there the glass slides and I tie them very well so that this crystal remains in one place. When I put there my bulb and I complete the circuit by completing the switch, it will produce light. While electricity has passed through the switch, through the filter paper because it is wet, through the crystal, and it will go. Though the bulb will produce dim light. Our intention today is to see whether there will be movement of crystals. So after setting up your experiment like this, and you have completed the switch, complete the circuit, complete the circuit by closing the switch. This will take around 15 to 20 minutes, and you will start seeing a difference. What will be the observation? What is the possible observation? Remember that we have copper 2 sulfate, which copper 2 sulfate is put on a wet filter paper, which has allowed electricity to go through it, and indicate that this battery, since this is the positive terminal, this crocodile clip is taken to have positive charge, meaning that this side will be taken to be the anode part of our experiment, and this side will have a negative. Copper 2 sulfate, which is in the middle, contains ions because it is an electrolyte. Since it is wet, because it is soluble, it will dissolve and will form our electrolyte, which contains ions. One of the ions is positive, and that is copper 2 ions, and the other one is negative, which is the sulfate. These two are here. You have completed the circuit, and you have here ions that are positive and ions that are negative. What will happen? From kinetic theory of electrolysis, copper 2 ions will be attracted more to the negative electron. Sulfate ions will be attracted to the positively charged electron. An indicator that a blue color will move to which direction? To the right. The right of the filter paper. Why? The copper 2 ions are attracted to the cathode. You will see some tailing of blue color like that. Some tailing of blue color, some stain that will be moving towards the negatively charged electron. Meanwhile, we shall have no colorless side. Why? What moves there is actually the sulfate. In addition to the sulfate, we shall have the hydroxide as well, moving that side, but both of them are colorless. An indicator that this is the only possible observation that we can see. Since these ions that are negatively charged are both colorless, we shall not have any observation towards the anode. How can you explain this? In words, in simple terms. In simple terms, the copper 2 ions are attracted and move to the negative terminal or negative end of the filter paper. this one is an indicator. Therefore, ions can move during electrolysis. I want you to take time and think about other colored ions. For example, if you have potassium permanganate. Potassium permanganate, which has this formula, and you, instead of copper 2 sulfate, use potassium permanganate crystal. Let me be specific. Let me call it potassium manganate 7. Manganate 7, which is KMnO4, and is used instead of copper. Instead of copper 2 sulfate. I want you to go and think about the observation state. What will be observed? State what will be observed. I'm sure you know the color of potassium permanganate, and you can easily know of these two ions, potassium and manganate 7, which one is colored, and the one which is colored, where will it move to? And always seek guidance in case it can't go well with you. For today, let's stop there. Do not forget to visit us on YouTube, Back Science Education Consultants. Do not forget to subscribe, like our videos, and share them with your friends. Say that you study together and you benefit. Make sure you keep safe. For now, we meet next time.